Hello guys, I'll show you my homemade system called Storage Manager. The system solves two tasks. First, node parameters management. Second, data transfer between disk pools. For now I'm moving away from ZFS, but I still use the word pool and I continue to call the disks as pools. The main screen is the host node section. Here, you can clearly see how many nodes are distributed across different branches and precisely which pools each of them belongs to. The left-hand column displays a hierarchical tree structure of servers and their associated pools. You can select several pools simultaneously from different servers, and your selection immediately affects what we see in the central part of the screen. Let's examine the central part of the screen. Here, you can see the node cards and their current status. The base color is a pale gray palette, like a morning in St. Petersburg, but problems will glow like a traffic light. Orange means we're getting ready. Red indicates it's time for repairs. Let's examine the node card in more detail. It has several badges positioned in its top left corner. The first badge shows the storage type. If a puzzle piece is depicted, that means storage is piece store. If you see a cabinet, it means the node has been successfully migrated to the hash store. A small green check mark indicates the synchronization status of all parameters in the database with their current state on the server. A dot positioned nearby indicates the presence of systemd unit files. If a node fails to respond to the API for a couple of minutes, its outline initially turns orange, and then, after a few more minutes, it becomes red. Within the node's interface, you can also observe its audit and online status parameters. Should a node enter a suspended state, its name will then be prominently displayed in red. As a matter of fact, I currently have one such node myself. Here it is, node 413, and it's currently suspended. The online status is red, and it's displayed separately. Let's return to our poolx pool. And let's look at the right side. If we select any node, we can edit its parameters. Some parameters cannot be manually edited as they depend on the node's location. However, parameters like wallet, email, port, and others that can be specified in the config file can be changed at any time. For example, let's edit the node's size. Its current capacity is 10 terabytes. Let's go ahead and set it to 5. The very moment that we save the repository, you'll notice that the checkmark badge then changes into an exclamation mark. This indicates that the parameter synchronization has been disrupted. A new value has already been stored within the database. However, the configuration file on the server still retains the old one. Therefore, we now need to perform a full synchronization of these parameters. After we have changed the parameters, we have 3 possible paths. The first is to initiate a redeploy. The system launches the playbook and the node deploys with new parameters. Once the redeployment is complete, the badge will return to its green state. We have just initiated the redeploy. We can go to the Tasks section and confirm that the redeploy task is currently in progress. From here, we can also view the log of the process. Excellent. The redeployment has been successfully completed. We can now return to the Host Node section and visually confirm that the indicator badge has turned green once more. Now, for the second scenario or option, let's imagine, for instance, that we have introduced certain modifications. The badge has changed again, and we can simply record the modifications without actually making any real changes. We've just noted that we manually synchronized something or simply entered some test parameters. There's also the term to default. For each node in the system, default values are pre-filled. These define how the port is formed, the storage size, where to send logs, and so on. In other words, all these parameters have default values, and we can also reset this node to defaults. So the node's size has been restored, and other parameters that would have been changed here, they are displayed in the current snapshot of changes, would also be restored. Thus, we've restored the node. We need to run a redeploy one more time. The node will be redeployed and everything will return to its place again. So the node has returned to its original state. Now it's back to 10 terabytes in size. And right now I want to switch the storage of these nodes to hash store mode. For that, I just select them all at once. Oops, I totally missed that. and I press the Run Full Hash Store Setup button for 4 items. If we go into the tasks, we will see that all 4 tasks are currently in progress. It will take some time, perhaps several minutes, but once that's done, the nodes will migrate to the hash store and the active phase of migration will then begin. Currently, I haven't yet developed a proper monitoring method to determine if the migration has fully completed or not, and I'm manually overseeing this process simply by observing the activity on the file system. Migration to hash store involves 3 tasks. First, stop the node. Second, create the quire files and make changes to the config. Third, redeploy the node. We're currently observing this process. Changes are being made at the moment. Here, the quire files and other things are being created, with values set to true. The redeployment has already commenced. Well, that's it. We've moved all 4 nodes to hash store mode, and active migration has begun on the hard drives. As we can see here, everything already has the new badges. Let's continue. Let's quickly go through all the buttons and checkboxes that are available here. The All Pools button selects all pools and inverts the selection. That is, you can select all pools and then deselect them. The Refresh Status button sends a request to the backend for a forced poll of the nodes via API to retrieve all fresh data, size, status, audit, and so on. Next come the checkboxes by statuses. There are nodes that might require redeploy. If we check this box, we'll see nodes that need redeploy. As we can see, we don't see any. There are none. No stopped nodes, no nodes without service. There's 1 node in suspend mode. And there are several nodes with online problems. One of them, in fact, is suspended. Here it is, the 413. So, you can add as many check marks as you wish, additively. So, all broken nodes will be shown, well, one way or another, either broken or problematic. Let's continue our tour of the interface. Now, let's navigate to the Host Pools section. This section allows you to view the capacity and types of pools and to modify certain parameters such as size, disk type, and file system type. The left-hand column displays a comprehensive list of all the hosts. Hosts can be selected one by one or several at once. In the center, pool cards are displayed. Here, the name, media type, and file system flag are shown. The pool fill progress bar is also displayed on the card. If a pool is filled up to 70%, the color will be green. If from 70 to 90, it will be yellow, and above 90, red. When selecting multiple hosts, a host prefix is added to the name. For example, on host 46, I have pool 01, and on host 42, there is also pool 01. If I select 2 hosts at once, 2 pool 01 will appear on my screen. To avoid confusion, they'll have a prefix. Please, host 42, pool 01, host 46, pool 01. Let me show how to change the pool size, and just find Edit and change the number of bytes. Up. The amount of free space instantly increased. Let's go back. The available space has decreased. I wanted to show you my killer feature. On host 46, we can clearly see that pool 03 is full, and we urgently need to take action. Otherwise, it will overflow and the nodes might either crash or simply stop receiving data. And I see several available pools here. Well, relatively available ones. So I can simply select a few pools and perform rebalancing between them. For this, I've chosen all the pools that will participate in this process, and I click the Batch Rebalance button. The modal window opens, and all my selected pools have already been loaded, and now I just need to choose the settings. If I check the box, Automatically Run Migrations, then after the batch is created, they will automatically start. Delete snapshots on the receiver. The system will automatically recognize from which file system to which file system the data is being transferred, and in cases where data is transferred from ZFS to ZFS, the operation will proceed using the send command. Consequently, snapshots will remain on both the source and receiver systems. Here, it's about the snapshots that would be on the receiver, in this case being deleted. If the migration is in the form of rsync, obviously there will be no snapshots on the receiver. There will just be clean files. Delete the source dataset. Well, this also remained from ZFS, but essentially it implies that after the migration is complete, the dataset or folder with the source node will be deleted. We click the Get Telemetry button. The system will fetch fresh data and calculate which nodes and in what volume need to be moved to balance the pool filling. The interface shows the total migration volume and the number of nodes that will be migrated. A detailed migration list will also be provided, including which nodes will be moved to which pool, broken down by each pool. We'll need to visually check which nodes will be leaving and to which pool they'll arrive. I've allocated 4 pools, but 3 nodes will be migrated to balance the occupancy. The 11th pool didn't make it into our migration because it was the most filled. It had only 6.2 terabytes free at the start of the migration. The other pools had more free space, so that's why they were selected. And after the migrations finish, the free space on the pools will be roughly equal. That is, the source will have 5.5 and this one won't be touched. Here, 4.9, 5.1, 5.5. That is, such a rebalancing will occur. After we press the Create button, a batch of type rebalance will be formed with all the selected nodes and the calculated telemetry, and then it will be visible, and we'll monitor it in the Batches section. Let's quickly go and check out the Batches section. I've already got a few batches that are currently running. The nodes are in the process of migrating. And here's the batch that's going to handle the rebalancing. And right here, we can see our 3 nodes, which will be going to the 12th, 13th, and 14th pools. And if we double-click on the batch file, then the actual migration process itself will be initiated. Here we shall see the progress bar. Well, it's only just now beginning to fill up. And then, of course, the logs. The remaining tasks are currently still waiting in the queue because the source pool is just a regular HDD drive, and I've implemented a system-wide restriction, allowing no more than 1 migration from HDD disks at any given time. If it's an SSD pool, you can perform several simultaneous migrations from it. By the way, here we see that the node size is 1,367 gigabytes, and 3.8 of them have already been transferred. So the estimated speed and estimated completion time for the migration at this rate. Yes, it's going to be floating around there, and if the velocity happens to increase, then consequently the duration will be reduced. Well, roughly, just to visually assess how long the migration will take. Here we have events that are currently unfolding. We can see what's happening.
A few moments later.
All right, we've finished with migrations. Let's move on. We'll pay attention to 2 related sections, VPN servers and VPN nodes. Let's start with the servers section. In this section, cards of VPN servers are displayed along with the number of IP addresses assigned to each. VPN servers can be added and removed, and IP addresses in each can be edited in the right panel. Let's add a new VPN server with multiple IP addresses. To do this, we press the Import IP button. In the import modal, just paste the IP addresses into a line, separating them with commas. If you paste multiple lines, several VPN servers will be created. Conditionally, 1 row equals 1 server, but immediately with a different set of IP addresses. The first IP address in the row is considered primary. That's the one that will be displayed on the server card. Let's enter another server, for example, with these IP addresses. We press import, and the system reports that 6 new IP addresses and 2 new VPN servers have been imported. Of course, they are at the bottom. Here we have the primary IP address, and here will also be the primary. And in the right part, we'll see our IP addresses. We move to the next section called VPN nodes. Here, schematically, the first column is IP addresses, then there's a list of nodes on it. We have a clear picture of how many and which nodes are assigned to the IP address. At the bottom, we'll see our 2 new VPN servers and their IP addresses, and nodes haven't been assigned here yet. There's a rebalancing function. If we press the rebalancing button, then nodes from more occupied IP addresses will move to freer ones. It will look roughly like this. We press rebalance, and some of the nodes that were here will go to the new VPN servers. After that, this can all be saved to the database and redeployed simultaneously. At this particular moment, we won't be doing this because our IP addresses are unofficial, but in general, the process works exactly like this. You can also move the nodes around manually, simply by dragging and dropping them to a row with a different IP address. It works roughly like this. We assign nodes to other IP addresses, press Save Changes to Database, and immediately launch Redeploy. All done. The system has started. To apply IP addresses to the nodes, and this is how it will look now. At the moment, these values, which have not yet been applied, are highlighted in red. After some time, they will become normal. Well, that's it. The nodes have redeployed with their new IP addresses, and now we have a slight imbalance in our IP addresses, which we are going to mitigate by first deleting these unnecessary servers that we only imported for demonstration purposes. Go to the VPN servers section, select all the unnecessary ones, and then proceed to delete them. Next, we'll return to the VPN nodes section where we need to confirm that our test VPN servers have indeed been removed. After that, simply click the Rebalance button. Oh, the nodes have successfully settled back into their original positions. We're also initiating redeploy, and we freely observe how this whole situation unfolds. All right then. The redeployment process has now been successfully completed. All the nodes have returned to full operation, and they are now residing on their very same IP addresses exactly as they were before. All right, everyone. Thank you all so much for watching. And with that, I'd like to wrap up this review of my storage manager. I truly appreciate your time, and thank you once again. That's all for now. Goodbye, everyone.